Continuing on with class 6, here's another example from our book, example 211. Propane in a still bottle of volume 0.1 cubic meters has a quality of 10% at a temperature of 15 degrees Celsius. Use the generalized compressibility chart to estimate the total propane mass and to find the pressure. Now this seems a little strange to me. I didn't realize you could use the charts in this way, personally. But remember that this thing is similar to being a vapor dome. So let's check it out. Let's see how we're supposed to approach this. This is the answer as they're showing, by the way. And as you'd imagine, when something is 10% vapor, they're showing it down here. I would have thought that it was up here, 10% vapor. Interesting. Anyway, let's check this out. Let's see if we can do it. So first off, we have propane. So we need some critical things about it. So here is our table. Is it 8.2? Yeah, 8.2. In 8.2, we go to propane. We're at propane. Why are you hiding from me? Oh, you're all the way down there. Okay. All right, so propane has critical temperature of 369.8 and a critical pressure of 4.25. Okay, sure. You say so. So we have a critical temperature, 369.8 degrees Kelvin, and 4.25 megapascals. And if we wanted it, we could have our critical specific volume. Although I don't know if I want to. Oh, I'm about to turn those into feet. Well, recording too much of 20 videos, I think. Getting loopy. All right, so our temperature is given. Should have written out the given. Is going to be T over. Oh, sorry. 15 degrees. Boom. 15 degrees Celsius. That's the same thing as 288 degrees Kelvin. And so our reduced temperature is going to be the temperature divided by the critical temperature. So 288 divided by 369.8. And we're left with a 0.7788. And if we go to D1, and we have a 0.778, you can see that we're somewhere in between these two. All right, so somewhere in this zone, like we could kind of like visually interpolate and find that we're going to be more than halfway, somewhere like right in there. Somewhere up in here, and because I have a copy of this, I don't have to print. So let me double check something first off. That kind of tells us that we probably have a pressure, because we know that this right here is where the pressure ratio is going, and we know these things are related to each other. So 0.2 isn't of the reduced pressure is kind of in line with this. Right there. If we think it's going to be on this line, if right here is saturated gas and right here is saturated liquid. All right, so this is, okay, so this is the majority of gas. Here's the majority of liquid, and we're like down here somewhere, but it doesn't matter. We're going to be in between these two places. So we're going to estimate that the pressure ratio is approximately 0.2, right? And so that means that we could estimate the pressure right away and find the pressure. So we say that the pressure is going to be the reduced pressure times the critical pressure, or we could say that it's 0.2 times 4.25, right? And if we were to do that, we'd get 850, well, 0.8, we get 0.85 megapascals, which is 850 kilopascals. Okay. And now we might want to say, okay, well, we're going to try to figure out what our compressibility factor is going to be. And it's going to be somewhere in between here and here. So we can kind of treat this as like a Z fluid and treat that like it's a Z gas. And now we can find what our compressibility is going to be. We're really just taking a look and seeing how far along this scale are we dealing with here. So if we very carefully pull this off, we could say, and somebody did this for us, but I don't like it, relying on it. They said that this was 0.05, right? The book is saying that this right here, where it crosses, lands at 0.03. I don't know, man. I guess I'm still looking at that. I think it's 0.05, basically. But I'll take their word for it here. And then this guy, they say it's 0.83, not 0.083, it's 0.83 where this crosses. And I can go, I can see that. If I wanted to go over here to prove it to myself, I'd go, all right, so here's my pressure 0.2, and then I'll go 0.03. Okay, yeah, that looks good. Yeah, that looks about right. Right, and then between 0.7 and 0.8, sure. I mean, I have all kinds of pencil marks on mine, but now I'm convinced. And then, like, if I come back up to this and go 0.83, boom, you can see that's where that crosses the line right there. Yeah, I'll buy it. But it really is sometimes challenging to get something off of this correctly. So let's say that we have Z of a fluid is approximately 0.03, and we have Z of a gas at 0.83. Well, if we want to find our Z, same thing that we would do normally. Fluid plus X times, but we don't have gas minus fluid, so we'll put it in here. This isn't how they did it in the book, by the way, but it comes out to the same thing. And I think this is what we're familiar with already from having used the steam tables. So we got 0.03 plus, and we said it was 0.1, so it's because it was 10%, right? 10%. So, and then we go 0.83, right, minus 0.03. And what we end up with is 0.1100. So that's our Z. So if we had this right here to find the specific weight divided by, so this is Z times R times T divided by P. So we go 0.11 times R, and we need to look up R. So R from table A 0.5. For what are we working on? We're working on propane. And propane has an R. Here, an R of, where'd you go, propane? Where'd you go, propane? There you go. 0.1886. 0.1886. Remember, these are kilojoules per kilogram degree Kelvin. But we would rather have it as Newton meter. So I'll multiply it by 1,000. And then I'm going to multiply the temperature, which is 288 Kelvin, and divide it by, what do we say? We needed the pressure first, right? So we decided that it was going to be 850. So go 850,000 to get newtons per meter squared. And we're going to get 7.029 E minus 3 meters cubed per kilogram. And we were asking for the mass. So if you take the volume divided by the specific volume, you get the mass. So you had 0.1 cubic meters and divided by 7.029 E minus 3. You get 14.23 kilograms. And this is slightly off from the book, I believe. I took a little bit of a liberty or two with figuring this out. I don't know if we can establish this because I don't think we have propane. We don't have the equivalent of a steam table. I say steam table loosely. So we have nitrogen and we have methane, but I don't think we have propane. Nope, no propane. So we don't have a means of double checking our values, but I'm sure someone somewhere, people in the propane industry, propane and propane accessories. Hank Hill, you see King of the Hill? Ever watch King of the Hill? Nobody watches the same TV. All right, that's fine. So anyway, and nothing more to say. Goodbye. Go away.